We're now going to look at how some activities can be called critical activities in a project. We're going to look at how critical activities can form a critical path and how delaying these critical activities can affect the overall completion time for a project. First, complete part A of this question. This is taken from AQA Discrete 2, June 2016, and it's question 1. We're then going to go on and look at how we can answer part B. So part A, we're going to start by completing the earliest start times of each of the activities in this network. So we're going to start with all of the activities that have no immediate predecessor. In this case, activity A, B and C. We're going to give those all a start time of 0. We're then going to consider any activities where their immediate predecessors already have earliest start times. So let's look at D. D is preceded by A and B. We can see that if we take A, 0 plus 8 gives us 8, 0 plus 6 for B gives us 6. We're going to take the largest of those two and give D an earliest start time of 8. I'm going to continue in this manner. So we can now look at activity E. Activity E only has one predecessor, which is D. So if we do 8 plus 6, we get 14. Activity F, again, activity F has two immediate predecessors, D and C, so we want to find the largest sum of the earliest start time and the duration. So for D we've got 8 plus 6, which is 14, but for C we've got 0 plus 22. So 22 is going to be the earliest start time for F. G only has one immediate predecessor, which is C, so 0 plus 22 gives us an earliest start time of 22 for G. H has one immediate predecessor, which is E, so 14 plus 14 gives us 28. I has three immediate predecessors, so we're going to consider the largest sum for E, F and G. E gives us 28, F gives us 27, and G gives us 29, 22 plus 7. So we're going to use 29 there. J now, we've got two predecessors for J. We've got H giving us 28 plus 13, I giving us 29 plus 12. They both give us a total of 41. If we look at K, K has one predecessor, which is I. If we do 29 plus 12, that gives us 41 for K. And finally, L has three immediate predecessors. So if we add together those, we've got 41 plus 8 for J, 29 plus 12 for I, and 41 plus 9 for K. So the 41 plus 9 gives us the highest number. So we can have an early start time of 50 for L. We've now completed the forwards pass, so we've got the earliest start times. We can now start with the latest finishing times. So L has got a latest finishing time of 50 plus 8, which is 58. Let's work backwards now and fill in the rest of these. So if we look at J, J only has one direct successor, which is L. So if we do 58 take away 8, we get 50 for J. And if we look at K now, K again has one direct successor, so 58 take away 8 is 50. I has three immediate successors, so we need to take the smallest out of 50 take away 8 for J, 58 take away 8 for L, or 50 take away 9 for K. So the smallest of those is 50 take away 9, which gives us 41. H has got one immediate successor, so 50 minus 8 is 42. E has two immediate successors, so H gives us 42 take away 13, and I gives us 41 take away 12. So both of those are going to give us, they're both going to give us 29. F now has one immediate successor, so if we do 41 take away 12, that also gives us 29. And G, if we do 41 take away 12, again gives us 29. D now has two immediate successors, so we've got 29 take away 14 from E, or 29 take away 5 from F. We need to take the smallest answer, so 29 take away 14 gives us a late finishing time of 15. Then A, we're going to get 15 take away 6 from D, which is 9. B is also going to have 15 take away 6, so a late finishing time of 9. And C has a choice of either 29 take away 5 from F or 29 take away 7 from G. So we're going to go with 29 take away 7, which is 22 from G. So that is the answer to part A. We're going to revisit this later in the question once we've looked at critical activities, critical paths and float times. So in an activity network, a critical activity is an activity where the difference between the start time and the finish time is the exact same as the duration of the activity. In other words, there is no wiggle room. It has to start and finish at those stated times. If an activity is not critical, that means that you could delay the start slightly and still finish before the latest finishing time. The amount of movement room that it has is called the float time. So the float time can be calculated by finding the finish time, take away the duration, take away the start time. Anything left over is the float time. If we get 0, that is telling us that there's no float time, so we've got a critical activity. So we're going to look at which of these activities are critical and what the float time is on the non-critical activities. So the critical activities we can see are A, because it's got a start time of 0, a finish time of 4, and the duration is also 4. C also has no float time, so that is a critical activity. D is critical, H is critical, I is critical, and J. So every activity network will always have at least one critical path leading from the first activity to the last. If there isn't a critical path, that means that the activities could have been completed sooner, which means that there would have been some kind of error in the calculation of these times. So the float times, the non-critical activities. B has a float time of 6 because the difference between the start time and the finish time is 14, whereas the duration was only 8. E has a float time of 3. F has a float time of 5. G has a float time of 2. So a path of critical activities from the starting node to the final node is called a critical path. In this case, the critical path is ACDHIJ. Suppose we're now told that activity B can't start until after activity F has been completed. We want to know how this might affect the overall finishing time, which has currently been calculated as being 15 for the entire project. We also want to consider whether that affects the critical path. So what we could do is redraw part of the network, moving B after activity F, and then rejoining it to activity J. We also need to remove some of the calculated early start times and late finishing times, the ones that are going to be affected by this move. We can keep some of the earlier ones as they are. If we now recalculate the earliest start time, we can see that for B, its earliest start time is now 9, coming after F. We can then see that for J, the earliest start time is now 17. That's coming from B, which is 9 plus 8. So adding on the duration of J, we get 18, which means that the overall project has had its finishing time, its overall finishing time increased from 15 to 18. If we then do a backwards pass to work out the finishing times, fill these values in here, we can now see which activities are now critical. So now the critical activities are A, C, F, B, J. Okay, let's go back to the question that we did at the beginning. So we can now find the critical path of this network. So we're going to initially look for the critical activities. We can see that C is critical. We can see that G is critical because the difference between 29 and 22 is 7. We can see that I is critical. We can see that K is critical and L. So the critical path is CGIKL. We now want to find the float time of activity F. So we can see that activity F has a latest finishing time of 29 and an earliest start time of 22, which gives a window of 7 in order to complete the activity. The duration of the activity is 5, so 7 minus 5 gives a float time of 2. So the float time for activity F is 2. Now please complete exercise 4.2 on page 64.